Okay, I feel like I'm audible, right? And I quickly give me a confirmation in the chats if you can hear me properly and if my screen is also visible. Yeah. Yeah, quickly give me the confirmation if I'm audible to everyone and if you can see my screen as well. Great. Hello, good evening, Akash. Good evening, Ramaya. Yeah. Hello, good evening, Sutendra. Yeah. Great. Good evening, Sanket. Good evening, Ankit. Akash, yes. Okay, yes. Okay, this is for sound, I believe. Yeah. Great. Your voice is clear. Okay, great. Chalo. So we'll be starting at 6:05, right? So that everyone can get the notification and they can join. Till then, what you can do is you can quickly tell you which day you are joining. I mean, is it your first day, second day, or your like fifth day or sixth day, right? Okay, I think there is one. Just a minute. Yeah, I believe this is day six, right? Just a minute. And there's a minor correction in the This is the day six, right? Just a minute. There is a very minor correction over here. Let me click clear that. Yeah, cool. It's fine now. So which okay, it is your fifth day. Okay, yeah. And you can also tell which college are you from, which branch are you from, right? And maybe which program are you from, right? Maybe I we have seen this in our initial session that people from MCAs or people from pursuing PCAs or BTechs are also joining, right? So you can quickly introduce. I mean, not exactly full introduction, but yeah, you can tell which college are you coming from. Stuffs. And for those of you who have joined for like other days, right, who are joining for fifth or sixth time or joining for second or third day, how was your experience from the past days, right? How was your experience with day 1, 2, 3, 4 and 5, right? And are you learning something? Yes, so you can also share that. And if you're joining for the first time, what are you intending to learn from these boot camps? Okay, great. Intake third year. I see third year or Ash year. What is? Oh yeah, third year. ENTC information technology. Great, great. Cool. My first line. Okay, great, great, Akash. Okay, so for those of you who are joining for the first time, right? About almost at the end of this session, we'll be pasting the attendance link, right? We'll be pasting the attendance link in the live chat, and you have to fill that, right? You have to also fill your feedbacks, and you have to fill your whatever learnings or whatever you got from this session. And based on that, I mean, based upon your details, you'll be receiving your certificate of participation over your mails, right? And for those of you who have been joining from day 1 until till day 7, right, who have completed or who have joined every class of this bootcamp, they'll be giving the certificate of completion, right? So all these things will be given into your email IDs. Exactly. Okay, thanks, Ramaya. Right. Yeah, I remember you joining for 1 2 hour sessions as well. Yeah, thanks. That it's really appreciable that you are liking these sessions. And great. Sure. Okay, so it's 6:05, right? Sure. So let's start the session, right? Because people will be joining in the way. So let's start with the today's agenda, right? So what we are covering right now. Just a minute. So if you remember in the last class, what we did, we did talk about. So it would be only explanation of coding also. See, Akash, in this bootcamp. Okay, so I have not taught anything, so I'll repeat everything. And see, Akash, what I was trying to say, okay, in these boot camps, no, yeah, so certificate, let me tell you in a minute. I was telling ki in these boot camps, right, we are discussing about the different type of data structures, right, and what is the use and how they are implemented, other things, right. So mostly there will be the explanation part only, because in 7 days we are just taking overview of everything, right. Something, I mean, some short demonstration or some short code explanation will be there, right. But due to time constraint, we are not going to everything. About the certificate, what I was saying is ki, if you are joining for every day, right, if you have joined all these 7 sessions, and if you filled all these attendance link as well, then you'll be getting the certificate of completion as well, right, over your email IDs. And if you are joining in for like any 1 or 2 session, and I mean, if you have not joined all the 7 sessions of the bootcamp, right, then you'll get certificate of participation, right. So this is what I was saying. Yeah. And yeah, Ganesh, thanks for arranging such. Oh, okay, thanks. It's really appreciable that you guys are liking it, right? You guys are giving this so many great feedbacks and response, right? So yeah, depending upon your responses and upon your feedbacks, we will definitely be arranging more such boot camps, and maybe more intensive boot camps in the future as well, right? Because these are just the introduction only, right? Cool. So without doing any further ado, I mean, let's get started, right? Let's jump into the bootcamp, right? So the very first thing that I want to address over here is what we discussed in the last class is about different other important data structures, right? And in that we just took a overview of every data type, right? And we discussed linked list in detail. So what we are going to do today over here is we'll be having a short, we'll be having a short just a minute, let's go to the next part. Yeah, we'll be having a short discussion upon these data structures now, right? Upon stack, queues, priority queues, and heaps. We'll see some of the operations, like what all operations can be done on stack, or how do we do these operations, about queues, about priority queues, and about heap. And once we have them, I mean, for the next session, for the last session, by the way, we'll be discussing about hashings, and we'll be discussing about graphs, right, in detail. And yeah, that will be all for this bootcamp. And I know many people will say, okay, we have just covered the theoretical part, we have just covered the explanation part, right? So because everyone knows, right, we cannot cover everything in these brief span of time. So yeah, I hope at least you are getting an idea what all we should have, and what all things we do. So that is, I think, that might be useful for everyone. Okay, got it. So thanks. Very okay. Thanks, Ganesh. First of all, thanks for okay. Thanks, Ramaya. Right. So let's jump into coding, right? I mean, let's jump into the explanation part. So yeah, these all are the indexes, right? These all the agendas for today. Now let's see what we have first of all. First of all, we are having stacks only, right? So stack may, although I have explained all these things earlier, but yeah, let me take out a moment and let me explain all these things in a in a much descriptive manner now. So as I already told you in the last class, stack is basically what? Stack is basically, you can say that if you are arranging something over the other, right? If you are, maybe I have given you this shuttlecock example, right? You have a box, generally have a box, and wherein what you have your shuttlecocks, right? Something like that, right? So understand it this way, you are placing your data, you are placing your any information one over the other, right? And the only constraint and the only thing about it is you will have only one direction to put that data, right? It is some container, right? What you call as a stack. So in this, what will happen is you will have one way from where you will put your data, and from that way only you will push out your data, right? you'll remove your data. So this is basically a stack, right? And also, since this is a linear data structure, right? What do I mean by linear and non-linear data structures? Linear data structures bole to, I mean, linear data structures are those wherein data or information is arranged, in a linear manner, right? One information is attached to other, and the second is attached to third, and things like that. There is another type of data structure that is called as a non-linear data structure, right? If you remember, we talked about trees in the last class, right? So in maybe arrays, in maybe linked list, everything may one node is connected to other, right? This is a linear one. You can call it a linear one. In non-linear, what generally happens is ki maybe one data is connected to two data, or maybe multiple data, or maybe they are interconnected to each other at some other point. So these are basically non-linear database, right? It's just simple plainer Hindi version of that, right? If you know the meaning of linear, if you know the meaning of non-linear, then the data structures are also working in the same way, right? Sure. So first thing is it is a linear data structure, right? So every data will be connected to one other node, or maybe one every data will be followed by another data, right? And which follows a particular order, right? So this is a important thing which on which the operations are performed, right? The order are LIFO. I have okay, stack may we don't have FIFO. Acha, FILO is also a thing, but yeah, we was talking about LIFO, right? So let me give you a brief intro. I mean, let's jump into our whiteboard, right? And let's see over there, because we'll have to, just a minute, we'll have to discuss about the other important operations as well, right? How do we put your data? How do you remove your data? So, and what are the applications of that? So you understand it this way, ki whenever I was talking, ki there is a certain container you are having, right? This container is open from above end only, or maybe from below end only. What you'll do is you'll place your data. You'll say, acha, this is my data block number 1, data block number 2, 3, 4, and things like that, right? So it is very obvious ki suppose if you have put the data 1 number first, 2 at third, 2 at second part, 3 at third part, 4 at fourth part, right? And if you want to take out this data, so will you be able to take out this data at the very first moment? No, right? You'll never be able to put out this data at the very first moment. For that, what you have to do is you have to first of all remove the fourth data, then you have to remove the third, then you have to remove the second, and then at the end only you'll be able to retrieve that. Right. So this is what we call as, what was this data, right? This was last in, I mean, maybe if you consider this only, so last in and first out, right? So this is a this is a terminology that we use, or maybe there was one more terminology, right? What was it? First in, last out, right? So these are things that we, these are the terminologies that we use whenever we are talking about stack, right? I hope this is understandable to everyone. The last in, first out bole to, the value that was inserted at the last moment will be inserted out first, and the value which was inserted in the first moment will be inserted out at the last, right? If you talk about this in a very general real life analogy, you can understand it this way. Maybe one shuttlecock example I've already told, but maybe if you are I don't think if you are able to recall that or not, because those all were what pre-pandemic era things. So maybe when I was in my school or when I was in my college, what we used to do is we used to stack up our assignments, or we used to stack up our notebooks for the submission, right? Teacher used to say, submit your notebooks, right, on the table or on the desk. So what we used to do is we used to put one notebook over the other. So this is an example of stack, right? You're stacking notebooks over the other. So in this situation, this is a stack thing. And now let's talk about some operations, right? If you have this container, or if you're talking about these normal books area. So in this, whenever you are putting something into this, right? Let me write it. Whenever you are adding something to it, in technical terms, or whenever we are working with stack, what we do? We say we are pushing things, right? The operation is push operation. The second operation is what? Whenever we are removing things. Remove operation is what we call as pop operation, right? So these terms are super important, because you cannot say I'm adding, although you can say I'm adding to the stack, or I'm removing from the stack, but technically you have to say I'm pushing something into the stack, or I'm popping out something from the stack, right? Other thing is there is something called as a peak, right? Peak bole to, you are looking at the first, or you are looking at the last entry that your stack has, right? So this is your last entry in your stack, right? So peak may you can get last element or last data. right? So yeah, this is about peak thing. And one more super important thing about stack is whenever you are working with stack, right? So you can see there are multiple data one over the other, so you need to have one pointer or one marker, right? As they call it as what, as a pointer, right? So this pointer is generally called as a top. So whatever you value have, right, it will point to the last index, right? It will point to the last value that you are having, or maybe the last the last index where you want to push your value, right? So initially consider this as your initial stack, right? If you have nothing over here, what will your stack point to? Your stack point to maybe -1, right? If you have one value, so what will your stack, your top pointer will point to? Your pointer will point to this value, right? If you add one more value, your pointer will start pointing to that value, right? So why is there a need of using a top pointer is very obvious, right? Because if you are pushing something to your stack, right? If you have a container and you cannot see inside the container, right? Maybe it is a transparent, I mean, it is a, what do you say? Translucent as this way, or opaque, right? If it is opaque and if you are putting out something over here and if you just start dumping over it without even knowing what is the what is the last index or what is the height until which the container is filled, so then you might encounter a situation wherein there is a situation called overflow, right? So overflow is also a situation. Overflow bole to you have exceeded the length of your stack, right? So in order to to take that into control, what you do is you generally take up a pointer top, and you constantly keep on checking it if our top pointer is if our stack is not full or not, right? So that is one more thing that you need to know. Overflow is a condition, right? Now there is one more thing. Maybe suppose one day you want to check if your stack is empty or not. So one way to do that is maybe you can directly check if the top pointer is -1 or not, right? Or maybe if you are if you are implementing it with some other way, then you can also what you can do is you can say that is empty is a function, right? Whenever you are working with stack, is empty bole to this will give you a true and false value, right? This will return a boolean value. So if this is false, I mean, if this is empty, then it will say okay, true, right? If this is false, then it will give you, I mean, if this is not empty, then it will return the false, right? So these are the thing about the common operations with stack, right? So let's take up some questions if you are having something. It's only extension. Okay, can you repeat? Okay, it's very good. Conducting. Okay, stack is linear. Yeah, exactly. Sequential manner. Exactly. Question mark. Yeah, great. So yeah, this is about the basic operation on stack, right? And let's go to the slide and let's see what all else we have, right? So this is, I've already told you, right? Insertion and deletion, how do you do it? Then there is something called as a push operation, pop operation, I've already told. Empty is I already told, right? Full is also one other method that you can use with it. If you want to check if your array is full or not, right? By full, what you mean is if the size of your array, the size of your stack is full or not, right? So that you can also do. One more additional information that I want to give over here is whenever we are talking about stacks, right? So stacks can be implemented with multiple things, right? Stacks can be implemented with, just a minute. You can implement stacks with what? Implement stacks with the arrays, right? So arrays you can you can simply track it. So if this is your array, right? Or maybe let's call it, make this in normal horizontal way only. So if this is way, what you can do is you can say every time what you'll do, what you'll move forward, you'll move your top pointers, right? And maybe suppose if you are at this point and if your size is exhausted, what you can say, if we are at the last index of our array, we can say that our stack is full, right? But again, another method of implementing a stack is using dynamic memory, yeah, or what do you say as linked list, right? Linked list, you can also implement your stacks. So in that manner, what you'll do is every time you want to add a node, or every time you want to add your value, add some value to your linked list, what you'll do is, first of all, what you'll do, you'll make a value. I mean, suppose if this is your top, and every time, suppose I want to add another value, so you'll create a new memory block, right? And you'll add that into this area, and then you'll move your top pointer to over there, right? Again, if you want to do this again, you can again create a new block, and then you can point your top pointer over there. One more thing is, now in this situation, you will say, this can never go out of our memory, right? Is this a thing or not? No, right? Why no? Because see, if you are creating multiple elements, right? If you are say creating million, billion, or gazillion elements, right? At some point, your memory will will be going to exhaust, right? You cannot create infinite number of blocks, or you cannot store infinite number of storage in your system. So that is why how do we know if our stack is getting full or not in such a situation is there is something called as a new. Right, I told you in the last session, whenever you are working with C++, right, whenever you create a new memory block, whenever you create a new chunk of memory, you create that with using new keyword, right? And whenever you want to delete that block, you delete that using delete, right? And compare it with C. In that, what you do, there is something called as a malloc and kellogg, right? There is something called as a malloc function and a kellogg function. So suppose if your new function is not returning anything, it is returning maybe like null, or maybe not returning anything. In that situation, you can say, Acha, we have run out of our memory, and then we can say our stack is overflow, right? So this is about it. And now let's see what all function. Okay, count is count, change, and display are other important function as well. See, now if you want to check what is the size of your stack, right? So one thing is you can iterate over simply from starting from top and then move ahead, right? And you can count the total number of nodes or total number of elements that you have in your array. But you don't want to do that every time, right? So there is one more function to do that. That is called as a size. Sorry, there is something in Java. It is size, but in C++ you have something called as a count function, right? So count will give you the size of your size of your stack, right? Again, there are other functions as well, right? It will say change. It will change. Suppose if you want to change any particular index, right? If you want to change, suppose if this is your stack, right? And if you want to change the third index or the third value of your stack, how will you do that? You do that using a change function, right? So there is a other function. Now, whenever I'm talking about all these functions, so it is not like that you'll have, see, stack, maybe you can also do stack in two ways, right? What two ways? One could be you create your own stack, right? How do you create your own stack? If you remember from the last class, I told you about linked list, right? In the linked list, I told you you'll have to do one thing. You'll have to create a node wherein first thing is you want to put the data. Second thing is you'll do what? You'll place you'll have another block wherein you'll place the address of the next block, right? Do you remember this or not? So if you want to implement linked list on your own, how you have to do is you have to use a structure maybe, or maybe class, and then you have to implement or you have to write every function from your own. But there will be very, I mean, suppose if you are doing solving or any doing any other operations on stack, and you know not to create it from very fresh every time, right? So there is one thing called as an STL in what? Just a minute, where is my pen? Yeah, there is something called as an STL. It's CSS, I mean C++. So STL bole to standard template library it is, right? In this, what will happen is all these stacks, right? All these queues, linked list, right? I'm writing LL for short, right? All these things are already implemented, right? And there are also plenty other functions, plenty other classes that are already implemented. So these functions that I'm telling you right now, right? Dot push is something, dot pop is something, dot count is something, dot change is something, right? So all these functions are, by the way, written already in your STL, right? So that is what you can take use of it. Now you might ask, what is the method of using STL, right? How can we implement that? Or can you show a demonstration of that, right? So don't worry, let me explain everything first of all, and then I'll show you quick demo of how you can implement it, right? Again, I'll not be writing everything from scratch because the time won't allow me to do that. But yeah, we will see a short demonstration about how do you push, how do you pop, count, and change, etc. Right? Similarly, as we this is all about the stack, right? If we move to the if we move to the before moving to the queue, there is something called as an application of stack, right? Before that, let me clarify this. Not only stack has all these operations, but queue also have all these similar operations, right? Queues, maybe you can also add something, you can remove something, you can get the size of queue, but the catch over here is queue will not have the same functions, right? Queue you cannot do the push, you cannot do the pop, you cannot use the although you can use something as a peak or pole, but the thing over here with the queue is that there are the operations over queue are something different, right? The name are also different. That we will see as we move on with the queues. So before moving to the next pointers, right? Before moving to the queues, let's quickly see what could be the possible applications of stack, right? So let me tell you this: there are plenty of applications of stack, right? Not only by for us to solve some problems, but computer or maybe some other systems also use the methods of stack, right, to solve some of the problems. So one thing that you might have encountered, if you are the science student, I mean, the computer science students, or maybe if you had something called as, data structures or something, maybe briefly in your subjects. So you might have encountered something called as infix and postfix of operators, right? So what are these operators and how these are, handled with the help of stack is also a different thing. Don't worry, I'll not be covering, I'll not be taking much of that into depth. But the catch over here is ki, stack can also be used, right? Stack can be used. There is something called as infix operators. Let's take different pen because black is not looking very good. So yeah, I'm saying ki there is something called as an infix operator. There is something called as a postfix operator. And one thing, prefix operator, right? So all these things you want to convert infix to postfix, maybe postfix to infix, or all these things, right? Interchangeably, you want to convert some operator to this or that. You can easily do that using stacks, right? That is a separate thing. There is a particular way how do you change it, right? And there is one more other thing. If you want to evaluate any particular particular expression, right? If you have something called as a prefix operation, right? If you have some operation, maybe plus plus a b, anything like that, right? This is just a syntax of writing these expressions. So if you want to evaluate this, what will be the value of that, or maybe 10 20 plus 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 10 20, anything like that, right? So how you how will you evaluate that? That is also done using stacks, and we will not be seeing how do you evaluate this or how do you convert this right now, but yeah, this is one such operation. Other important thing is called as a balancing of symbols, right? So if you have tried putting something, you might have encountered across this problem that is called as balance parenthesis, right? Or balance balance these commas, or balance all these things, right? So this is a very classic problem, like that that is done using that is done using stacks. Again, we'll not be looking into that core or how this is done, but yeah, this is one crucial method where this is one crucial problem where stack is used. Again, the very simple example of that would be how do you reverse a string, right? So string reversal is a very simple thing. You can guess it also how string will help us in getting a string reverse. So this is a very simple example. Let me give you the intuition behind how you can do that. Right, so the answer is very obvious, right? Maybe suppose if you want to say, yeah, I have maybe something called as a B C D, right? If you want to reverse it, maybe you can directly run a loop from behind, and then you can say, yeah, this is my reverse version. But stack heavy, you can also do that, right? How can you do that? First of all, you will start pushing each character in your string. You'll say A, B, C, D, right, one by one, and as you start popping them out, right, as you say, pull out the D, right, or pop the D, then you'll write it over here, then pull out the C, right, then B, then A, right? If you notice this, the string is reversed, right? So this is another way of writing, or this is another application of basically reversing your string using using stacks, right? So now I hope string might have given you some ideas, right? Sorry, stacks might have given you some ideas. Now let's discuss about the queues, right? What is queue and why or where they are possibly used. So queues, if we have to explain queues with the help of a real life example, right, we can understand it this way, right? In the normal real life queue that we have, right? Maybe we have a bank or something, right? Let's call it a bank. And you might come across these queues, right, wherein people are standing in line to get their job done, right? Maybe to withdraw money, maybe to do some paperwork or something. So this is basically this is basically queue. And what are the fundamental rules about queue? The fundamental rule about queue is every new entry will be added from the behind, right? Suppose if this is the start, right? So no new person will be allowed in middle, right? And no new person, although many people bumps into the middle, right? They just give some excuse and they bumps into the middle. But yeah, jokes apart, the thing is that whenever you a new entry or whenever a new data is coming, so how they will come is they will come from the back side, right? They will come from the end of this. Or if you talk about the technical terms, right? The technical term about the end over here is called as a rear, right? So you will have 2 pointers. One is called as a rear, and you'll there is something called as a front pointer, right? And all these pointers that I'm telling right now, there is something called as friend, there is something called as a rear, right, or the top that I told, right? So these are the conventional name that we use, right? If you want to, implement your own stack, your own queues, and if you want to name them something else, right? If you don't want to name them front or rear, you are allowed to use any other terminologies. But yeah, these are the conventional name that we use, right? Sure. So that is why every entry will be added from the rear, and every person whose work has done or something like that, they will be removed from the front side, right? So this is about the operations or the basic things about it, right? Now let's talk about the operation name, right? If I want to add something to my if I want to add something to my queue, or if I want to remove something, how will I do that, or how will I do it, and what will I call it, right? So if you want to add something, right, want to add it, you will say what? In queue. Right, yeah, exactly. Like Ganesh told, the NQ is what? If you want to add, right? There is something called as removing. So how do you remove it? You remove by DQ. Right. And by the way, these are the name of the function that you will use whenever you want to add or remove something from your queue. Right. And how are these functions implemented? And how can I use that? Is already I told you that all these things are done in STL for you. Right, standard template library in C++. Or if you talk about Java, right? So the Java, there is something called as collections, right? So all these things are done in collections over Java and C++ में still. Python I have no idea, right? Because yeah, I rarely use that. So yeah, these things can be done in this way. Now, this is the basic example of using a queue, right? Now you can see that insertion will be done from the end, and deletion will be done from insertion will be done from the end, and deletion will be done from the front. And I've already told you there is something called as a front and a rear. Okay. Okay. So let's see what are the basic operation. Okay. Hello, Kirti. Yeah. So what are the basic operations, and what are the name of them? So the very first thing is enqueue. I already told if you want to add something, so you write this operation, right? You say we are enqueuing something. Okay, I have this also. So if you are adding something, you'll say you are doing enqueuing, right? Or if you are removing something, you will say what? We are dequeuing. Just a minute, let's take this color. Yeah, you are dequeuing, right? Now, what all things is, there is something called as a peak, right? We have discussed about this thing in the stack also. The peak is to get the get the topmost element, right? In here, we'll get the front element of the queue without removing it. Right. If you do a poll over here, poll will pull out that element for you. But peak will do one. Peak will just see what is the topmost element over here. Right. Is full and is empty. It is very intuitive, and it is. I have already told this as well. This means it will check if our queue is full or not, right? Or if our queue is empty or not. It will return the Boolean values for us. Right. Chalo. So if these things are clear, now we can quickly move over to the application of the queues, right? What are the basic applications of the queue? So queue is very important. Again, I'm saying queues and stacks are very important, not only to solve some questions for us, but also queues or stacks are used extensively in our operating system implementation, or maybe in our other system usage as well, right? So there is also one more thing that I forgot to tell over here is this is queue, right? You use which principle, right? You'll use what? FIFO principle. Why FIFO? Because the person who arrived first has to go first, right? Because we are disciplined manner. I mean, these people follow disciplined manner, and we will not bump into any other place, or we will not cross the line or something, right? Although there is a situation whenever we are talking about queue, in queue there is a special scenario, right? If you remember, I talked about priority queues, right? So priority queues, what will happen is, let's not cover priority queue right now. Let's for a moment stick to queue only. But queue what is happening is whosoever come first we will leave the first. So that is why it works on the FIFO principle, right? Just a minute. There is a replay. Yeah. So you already know now it works on the FIFO approach, right? First in, out, and it has to be implemented. Again, this is also our what? This is also a linear data success, right? Some common application of using these data successes, like you have heard this thing, right? There is something called as a CPU scheduling, right? Or disk scheduling, right? If you know this or not, the simple thing is whenever every program that you are running, right? Maybe I'm running this PPT, I'm running the slides, I'm running the whiteboard, etc., etc. So all these things, in earlier time, what used to happen is or maybe in the systems nowadays also, what is happening is ki you are not doing all these tasks in a simultaneous manner, right? You are doing what? You are doing some part of this first of all, and then the some part of other, right? So if you have plenty of tasks, suppose if you say, just a minute, suppose if you say ki you have some task, right? Task 1, yeah, you have this as task 1, you have this as task 2, right? Every other task a CPU has. So what will happen is ki all these things will come in a queue, right? This will be under a, you know, what do you say, a processing queue, something like that, and every task will be pull out first, it will be executed, and then we move to the next one, right? So this is about the scheduling, right? How your system uses it and all. Now there is a, yeah, I told this point, CPU scheduling or disk scheduling it is used, right? And hardware and real-time systems interrupts, maybe this is also used, right? Now these things might not make very sense to you unless and until you know something about operating system, right? Operating system tells you ki, how all these things work, or you know how your program will be executed, what happens if some conflicts happen or not, right? So all these things are somewhere related to it, but yeah, the core functionality is queues will be helpful in that, right? How queues will be helpful? Because queues will track which program came first, which program came last. So according to that, every task will be pulled out, and queues will be used to store those tasks first, right? Now handling website traffic is also a similar example of that. You can easily relate to that, right? Routing and switching in networking. See, all these things right now will require some of the other your information about networking or about switching and all. But the core fundamental or the core thing is ki you will have multiple things, right? Each coming after other, and in that what you'll do is you'll take out first task, you'll execute it, and then you move to the next task. Again, same thing will happen in your playlist as well, right? If you have like multiple songs, if you have 10 songs selected in your favorite section, what will happen? Each song will be arranged one after the other. If you skip that one, or if you play that one completely, then only you'll move to the next one, right? So this is another example of using queues for us, right? So I hope this thing might have made some sense to you. Now if we come to the next point, right, if we talk about the next point, that is a priority queue, right? So priority queue, as I was telling earlier, is a special format of a queue, right? Special form of queue bole to, see, I told you in this situation, right? And let's switch this example for a moment, right? Let's not take this as a bank queue. Rather, what's we have to do is let's take this as a hospital, right? The similar example that I've given in the yesterday's classes, priority queue, or as they call it, PQ. Right. So in priority queue, what will happen is ki there is normal queue, right? This is this normal queue. This normal queue, there is person 1, there is person 2, there is person 3, there is person 4, and so on, right? So there are multiple persons, and this is not a bank now, then this is a hospital now, right? So there's the spelling of hospital. Hospital, yeah. In this hospital, suppose every patient is over there, right? Some has a minor cold, some has a minor cough, some has mild fever, or some is severely injured, right? Some has just met an accident, or some is has some critical condition over here. So what do you think? Should they follow the normal queue, right? The minor fever person should go first, then the doctor should check him, and then they might the minor cold person or maybe some minor nail injury person should go first, or these person who have some critical injuries, or who have some things that need to be addressed very quickly, they should go first. Right. So the you'll obviously say that the persons who have these important situation, or the person who are in utter need, right? So they should go first. So exact thing will happen over priority queues only. Although we will not use a real life person, or we will not use a real life hospital thing in our programming, but the thing that we will do is, with every data, we might attach something called as what? We might attach something called as a priority number, right? Or maybe we might attach something as a number, right? Or maybe as a sign or something to understand that what is the priority of this number, right? Maybe we can do that, or one simple thing what we can do is, maybe we can start arranging, maybe we can just say, Acha, these are some numbers for us, right? Maybe there is 10, 80, then 1, then 1000 or something like that. What we can say is ki, suppose if I want to get the high, suppose understand them as your path, right? Ki this is 100, this is 10 meters, or maybe 10 kilometer, 80 kilometer, 1 kilometer, and 1000 kilometer, right? So if you want to traverse anyway, right? So what you will find is ki, acha, what is the shortest path? because you don't want to travel to very fast, very far away with the very first moment, right? Or you don't, suppose if these are your scores, right? Or if these are some, some values, maybe suppose let's take a scenario, you are a robber, right? Suppose you are a robber and you want to rob something, and you have some different task coming over a pipeline, right? Or maybe you have some different things flowing on for a pipeline, and these value have some value. I mean, these things have some values, right? Suppose if you are getting a normal like TV remote, right? At the second point, what you are getting a maybe a TV itself, and then you are getting a battery, or maybe at the last you are getting what? Maybe you are getting what? A MacBook or something, right? So you will first of all see like, so what is the most precious thing, because you might have very less time to rob all these things. So in that situation, you need the highest priority thing, you need the highest costly thing, because so that you can sell it and you can make some money, right? So how you can do that is, you will first of all see which has the highest priority. This has the highest priority, so this will come at the very first, right? So that you can pick it out first. So this is done using the priority queues, right? Or maybe the other thing could happen. Maybe suppose if you are arranging your things in a home, and you are saying, yeah, there might be case ki my things got stolen, right? So in that situation, you want ki you will have the least precious element at the first, right? Why? Because suppose if if someone started robbing it, then they will get the least valuable things first, right? So all these examples that I'm taking are, they're just like, what do you say, hypothesis that I'm taking, right? So don't understand or don't think I'm promoting robbing, or, I'm promoting some other things, right? It's just for a, understanding purpose. Right. So this is about, the priority queues, right? Although how implementation is done, how do we write program and all, these are not part of the bootcamp right now, because it is understandable that all these things cannot be done in the simple bootcamp, right? So this is about the priority queues, and priority queues may you also understand that there can be two types of priority queues. One could be wherein you are arranging in the max priority order, right? Max priority order. And then the second, what you are doing is you are arranging in the minimum priority order, right? So this is about it. Okay, so Ganesh is asking, sir, is it important OS for yeah, man, OS is also very important topic for for the interviews, and it is a very core subject, right? OS is important, networking is also important, right? So core subjects are also important for the interviews, so do study them. Okay, sure. So about the priority queues, I've already told, right? It is similar to queue and all the other information I've already passed. Right now, if we talk about the applications of priority queue, right? So priority queues is also extensively used, right? Extensively used whenever we, I told you about something called as a path, right? I told you, suppose if you are sitting, or if you are, let's take this example. This is something related to graph, but yeah, let's take a minor example. And if you get this example, then I hope you'll get key where could it possibly be used. Suppose in graph, what happens, or maybe let's not talk about graph right now, right? So let's say maybe this is a point where you are standing, right? And there are multiple ways to go. There are these different multiple ways that you can go over, right? This is road number 1, this is road number 2, this is road number 3, and this is road number 4, right? Now what you want to do is you want to cover the maximum distance, right, with in a limited particular time. So what you will do, you will say, will you go to the longest route? And you will say, I have conquered, maybe there are different rewards at each at the end of each road, and you have a particular time to collect each reward. So will you say I'll go the farthest the distance first? No, right? What you'll say, I have to go to the least distance first, so that I can cover maximum rewards. So this is something this is something that has to do with the Dijkstra algorithm, or this is something that has to do with the Prim's algorithm, right? All these things are graph algorithm, but the implementation is done using these priority queues only. Right, so this is the basic thing, right? Again, their scheduling is also done, right? Suppose let's take the previous example. You have multiple programs, right? You have your CPU has multiple tasks to do, right? So there is some shitty task called you are copy pasting something. Then there is important task you are running a server, or there is important task you are doing a payment or something, right? So you don't want to focus all your emphasis on that copy pasting thing first, right? You want your system to do that copy paste, that server running, or that processing that transaction first, right? So this is how how you want how will you tell your system your CPU execute this task first, because this is very important. So you'll say you'll prioritize them, right? How will you prioritize? You'll have some symbols, you'll have some values, or you'll have some other things, right? That is a different part. But the catch over here is there is something in the situation you might need to encounter, wherein you suppose if your task is at the least, if your task is at the very end also, but you want to execute it there first. So that is done using what using priority queues, right? So all these are the the example of that, right? Dijkstra, Prim's algorithm, data compression, Huffman coding, right? Heap sort. Okay, heap sort is a different thing, right? Heap sort, we have this in our PPT, right? So when we reach there, and I'll tell you there is priority scheduling, right? That I told you, load balancing, interrupt handling, and all these things are somehow related to the priority queue, right? So we have some other questions. Is it okay? The questions. What are the questions to ask? Interview after completion of boot camp, can you send to the PDF? The questions you are asking for the normal what DSA interviews, right? And Ganesh is asking for the OS interview. See, the catch over here is ki, the first thing or the basic thing about sitting for any interview is that not to just focus on or rely on these sheets. First of all, the catch over here is ki, are you able to understand the functioning of that or not, right? In OS also, they don't go for very high-fi questions, right? They first of all ask you, are you able to, are you clear with your fundamentals or not, right? Because if you are clear with the fundamentals, right, what are different types of scheduling, what is SJFS and other things, right? So if you are very clear on that point, then, you have a better edge over the others, right? So I'll suggest you study first of all, the basic points for clear, and if you are able to get the all basic things or all core things, right, then all these tricky question and all will not be very tough for you to crack, right? So this is what I'll say. And about the interview questions about that, right? So yeah, I'll let the team know ki, the attendees are asking for the interview questions for the DSA or for the OS preparations as well, and yeah, they'll forward that in your groups, right? So don't worry about that. Cool. So now comes an interesting part, right? That is about the heap. So I told you about priority queues, right? So somewhat you can say, acha, this is almost or maybe somehow relevant to the priority queues only, right? So what will happen in a heap, right? Although I've given this example earlier, but yeah, let's tackle this again. What is a heap first of all? So heap, you can say, just a minute, yeah. Although heap is not exactly a tree only, right? Every time it is not a tree, right? It can be implemented with the help of an array as well. But the catch over here is, suppose, let's for a moment understand this is a tree only, right? So the catch over here is, suppose if you have a data, right? Suppose if you have X value over here, and you might have some different what sub children, right? This is the parent, and you might have these as your children. So the only condition about being a heap is this value should satisfy the heap condition. The heap condition is what? If either this value should be greater than all of these, right? Maybe suppose y and z are written over here, right? So the condition could be if x should be greater than y and z at any cost, right? This is it. Or if we are talking about the minimum heap, right? There again can be two types of heap. One could be your max heap, wherein your parent is larger than what? Your children, right? Second could be your minimum heap, wherein what? Your children is, are always larger than what? You say, or second could be x is always smaller than y and z, right? So these are the heap condition. Now, whenever we are talking about heap, right? So it is not like heap will be, sorry, heap will be for one level only, right? You'll have a better tree. You'll have a very dense tree, right? Suppose let's take this example. You have this kind of a tree, right? You have multiple nodes. You have multiple childrens. You have this, right? Then you have this. Now, if we talk about this, right? If I tell you if this is a tree or not, you have to closely monitor that at every level only, right? You cannot just check if this is greater than everyone or not, if this is less than everyone or not. Although if you are maintaining a heap from below, right? If you are saying ki, chalo, if these values may, this should be larger than right? Suppose if we are feeling what? If we are feeling over 10 here and 11 over here, then if we are maintaining a max heap, what should happen? This value should be at least greater than 11, right? So it could be anything above 11. So let's say if this is 12, right? Then you'll again check ki, acha, suppose if this is also a child, let's write it as 30, right? So again, the next value could be what? Greater than, at least greater than 30, right? So this could be 40. Again, if you write it this way, then you'll have one thing. Then you can say for sure that every value that is at the very top will always be the highest value among your tree. Or if you're maintaining this as a min heap, what will happen? The value at the very top will always be the least value among your tree. Right, so this is about the max heap and the min heap, right? Now, how do you maintain it is a separate thing, right? There is something called a heapify, right? Heapify may suppose if you have removed this value, right? If you have removed that value and you have a different tree now, but suppose if every value is shifted by one node above, but the catch over here will be key, you need to rebalance those value again, right? Why you need to rebalance? Because the value might the tree might not be the perfect condition in right now. So that is how you can do it. You can do it using a heapify operations, right? So this is about what heap, and there can be min heap, there can be max heap, right? Again, it is not a case that you need to only implement heap with the help of a tree. You can implement that using arrays also. About arrays and how do you implement it is, again, I'm telling again and again, we are just looking into the brief explanation of everything, right? We are not going into the depth key how this is implemented, right? Chalo, so yeah, some questions. Okay, actually this is already done. Yeah, Navjot is asking for the attendance. Yeah, so Navjot, I'll be sharing link in 1 or 2 minutes, right? Around 55 something. So please wait for that. So this is about the heap, right? Now, what could be the possible use? Just a minute. Yeah, what could be the possible uses of heap? See, this is the example that I was telling about, right? Okay, this could be heap. Now, if you look very closely, right? See this example, then you'll have a better understanding over here. See, if this is a min heap, right, then the values are 40s and 50s, right? So this value is what? This value is less than 40s and 50, right? It should be less than that. It should not exceed it. Now, if the root are what? 40 and 30, the 140, the values is what? Is 30, right? Again, now these are two children for what? This root node. Now 15 and 30 may say what we have chosen. We have, I mean, the value is 10, right? Not even 15, not even 30. So if you look at it very closely, can you not say that this is the least value among this tree? Right? Why least? Because we are doing what? We are implementing a min heap. And one other added advantage of using heap is what? If you have maintained a proper heap, then you can say if you have to choose the least value among the tree, then it will always be at what? It will always be at the root element, right? This is, by the way, called the root of a tree, right? Again, if you look at it closely, 10 and 15 are there, so 40 is there. Then 50 may have 50 and 40, right? Then this is value greater than that, right? So that is why it is above over here. And at the top, right, at the root level, what you are what you are able to see, you're able to see that the maximum value across your tree is present at your root. So again, if you have to quickly find what is your maximum value, that you can do using what? That you can do using your heap data structure, right? Max heap and min heap. Okay, so these are the introduction to that. Now we have something called as a heap sort, right? So heap sort, if you remember closely, right, we talked about the sorting algorithms in like 3rd or 4th class. So in sorting algorithms, I've told you what? I've told you bubble sort, I've told you insertion sort, I've told you selection sort, quick sort was also there, and merge sort was also there, right? Then I told you there is something called as a heap sort as well, but we didn't look at it at that time, right? Why we didn't look at it that? Because heap sort requires you to understand the concept of heap and heapify, right? How do you heapify that? So that is why we skipped that for that moment. Now, if you know about the heap, right? So heap sort becomes very easy for you, right? The only thing over here is I told you about heapify, right? You'll do one thing. You'll say if this is a tree, right? If these are the value, maybe if this is x, if this is x and this is y, what you'll do? You'll arrange this parent node at least in a way that this value is greater than or less than what? Right, but again, you cannot say if this value is larger or if this value is smaller. So by repetitively doing that heapify step, right? If you do these the comparison step for every node, right? If you just check if this value is larger or smaller, similarly, then you check for every node. Can you not say that if you start iterating it, right? If you start traversal of this tree, right, you'll get a perfectly sorted array. Right, so that is the basic intuition behind doing a heap sort, right? Let's see what is the basic algorithm of doing that, right? Know that it is a comparison based sorting algorithm, right? How we why it is comparison based? Because we are doing what? We are doing comparison at every node, right? And that is how we are able to achieve this sorted sorted array, right? Then binary heap, data structure I've already told. See, always remember that binary heap bole to every node will have what? Every node will have exactly 2 children, right? So that is what we call as a binary heap, right? Okay, again, attendance. Just a minute. Let me share that first, because it's already almost. So, yeah, the attendance. Yeah, and so let's continue with that. What I was telling about the heap, right? So in heap, the heap sort basically, right? So Yeah, good evening. Hello, Hema. Okay. So the algorithm is basically you heapify for every element, right? You first of all do that. You'll receive the least element over your page, over the top, and you remove that, right? Where is my pen? Yeah, this is it, right? So what you do is you across your whole tree, what you find the least element in your page, right? You put it at the 0th element, you pull that out, right? Why pull that out? Because once you have got the least element in your page, if you will click it, if you'll pull that out, what will happen is then you'll again run the heapify program, right? Then you'll again run that heapify thing, and the second largest, right? The largest or maybe the smallest in your tree, right, which is at the current moment, that will again get replaced at the top, right? And again what you'll do, you'll again pull that out, and then you'll have what you'll have the third largest element or the third smallest element at your top, and then you can pull that out until and unless you have emptied your whole tree, right? So this is the algorithm, or this is the basic thing about using a heap store, right? Now, yeah, this is it. Okay, that is the basic, the end of the session, right? So we have discussed about what we have discussed about every important data structures. We have talked about what is stack, what is queue, what is basically priority queue, what is heap, right? We've also told about we also discussed what could be the possible operations that you can do with stack, with the queue, with priority queues, and with heap, right? We also saw what could be the implementation of that, right? Okay, so heap main, this is it. Applications and all are done. Queue is also done, right? Priority queue is also done. Heap is also done. So this is it for today. If you have any doubts or something, right? If you feel like asking something, you can ask, or we can conclude this. And for the next class, that is our last class. Basically, what we will have is we will have the concept of hashing. First of all, what is hashing and how can it be used in solving our problems or in computer fundamentals. And the second thing is what? Second thing is graph, right? We will have a discussion about what are graph, how they are implemented, and what are the basic or what are the general, the common important algorithms that we deal with. Right. So yeah, that is it for the session. Please fill out that attendance sheet, and yeah. If you feel like you are enjoying, or if you have enjoyed something, if you have learned something, please do mention that over the chat as well, right? So that we can get that motivation of going further. So bootcamp should have live on, because live question telling and asking as well. Oh, okay, that is a good suggestion, Ganesh. But the thing is, we want that bootcamp to be there on YouTube as well, because everyone will not be able to join that. To join the Zoom link. And maybe this is also what we can do is we can also put that video in our in a YouTube channel after that. But yeah, I'll definitely I'll let the team know about it, and yeah, we'll take your suggestion and we'll see if we are able to come up with this solution in the near future. And if you are liking this now, again I'm telling you, you can like this video, right? You can share this video amongst your friend, and you can consider subscribing to the channel, because it will give us some motivation to do more such things in the future, right? And you can check out two other awesome videos that are all already uploaded on these channels, right? We have we have covered like 4-5 days other we have covered. We have had the Java's bootcamp as well. We have had some roadmaps. We have had some other Q&A sessions and all. So please go through them. And yeah, that is it from my end. And I think it should be the end of this session. And if you have any quick feedbacks or suggestions, you can obviously drop them in your forms. And yeah, chalo, great. Okay, so yeah, I'm ending this session now, right? Because it is everything we have covered. And for the next session, we have for our last session, we have what? We have graphs and we have hashing. Right. So see you tomorrow, everyone. Bye and have a nice day.